Hey, scale to zero, scale to planet size when required, pay as you go billing, pay per second billing, a great developer experience with a clean programming model, a fully managed environment with a well-known operating model. These are some of the characteristics of a serverless compute. But how do we do this exactly? Let's try to find it today. Hi, my name is Raju Pillai and I'm a customer engineer at Google Cloud. I specialize in application modernization and I work on technologies related to Kubernetes. And this video is part of a GKE weekly tip series. So without any further ado, let's get started.
There is a common misbelief that serverless computing does not require servers. Well, that's absolutely wrong. Your application code has to run somewhere. It's basically the abstraction that is provided through different models that gives you a perspective that you do not need to deal with the infrastructure layer. So let's look at those. The first one is the operations model. So here you do not need to worry about the infrastructure, the t-shirt size and shapes of the compute nodes. So that thing is completely offloaded to the cloud provider via a framework that we will talk later. Similarly, the day two operations of scaling, whether scaling up or scaling down, all of that is again not your concerns anymore. There is no infrastructure that is created upfront or pre-provisioned. That means you actually create resources on demand and as required, and that's the reason it is very cost-effective solution. More often, your billings are also seconds or maybe 2 seconds or 3 seconds. So that's the kind of frequency at which the billing happens. Let's also look at the programming model. So of course, not all application can be deployed as a serverless environment. Especially those applications which have some sort of a state are not a good fit. The framework supports both the common programming paradigms, which is one is a request response, it's typically in HTTP asynchronous calls. At the same time, it also supports a pub sub or a publish subscribe model, which is typically of a queuing model or an event-driven systems. Of course, all of them are supported via an open architecture or open standards, and that's what we're going to talk about. Serverless computing in a cloud-native environment is often implemented as a Knative solution. So call it as a reference implementation or a platform or even a framework. So let's look into the architecture of Knative. So underneath, there is a platform, which is Kubernetes, of course. So that abstracts out all the infrastructure layer beneath. And now on top of that goes in a routing gateway. Now this routing gateway provides you an access route or path to the application that runs on that Kubernetes cluster. And hence it is implemented as a plug-and-play architecture. That means you can throw in a HTO open source gateway, or you can put in a Contour, which is a erstwhile Heptio or VMware project that basically does a multi-cluster ingress, or even the Ambassador ingress controller. So it's basically pick and choose plug-and-play architecture. So the next layer is really the Knative layer. We also call it as primitives or the core. So it basically had these three different subcomponents, which is build, serve, and event. Now build has now matured and no longer part of the Knative framework. It's a separate project altogether, which is called Tecton. Now that tries to solve the problem of doing CI/CD in a cloud-native environment in a consistent manner. So anything to do with building the container image from the source code, pushing into a Docker registry, and then pulling it off from there into a Kubernetes cluster. And entire thing about the pipelining to basically do this. So that is the concern that Tecton works on, and that's the reason why it is now separated out of Knative. The core component still remains as serving and eventing. So you may be familiar with the Istio style traffic splitting of 25% of the workload going into one revision and 75% of them the load goes into another revision of that particular application. So that traffic splitting, traffic migration from 0% to 100% onto a new version, config management, and auto scaling, right? I mean, based on the request per second load that comes in, or based on CPU or memory utilization, you want to basically scale your number of containers to take or handle that load automatically and in a very, very fast manner, right? Similarly, when there is no load, you come back to zero or scale to zero, as we say. So that entire thing is taken care by the serving framework. Now, eventing is slightly different, because eventing has to do with when we want to publish certain events either to a consumer running on the Kubernetes cluster or basically just produce that thing and don't care about like a fire and forget kind of a pattern. And of course, the next layer is basically the actual products, right, from different organizations. CloudRun is from Google, for instance, and CloudRun on GKE is again different variant. So the different organizations that is contributing to Knative framework now, as it is slowly becoming as a de facto standard, just like the way Kubernetes was a de facto standard for the orchestration layer, Knative is becoming a standard for deploying serverless application on Kubernetes. So these are project. Let's talk a little bit about CloudRun. CloudRun is Google's implementation of the Knative framework. So CloudRun is available in two different variants. First is the CloudRun fully managed. So this is a fully serverless technology. We do not give access to the nodes at all. So customers cannot do SSH into the node. And this is really pay as you go or pay per use model in which you don't make any upfront investment. And I would say that this is also the second generation of the very popular app engine that has been there in the market for the last close to 10 years. The second variant is the CloudRun on GKE. Now, this is basically extending that CloudRun abstraction and the experience beyond GKE to not only in other clouds as well as hybrid cloud. If you were to run it, the same experience of serverless. Let's do a quick comparison of both the solution. So the CloudRun fully managed, as the name suggests, is a fully managed solution. So you absolutely completely offload that idea of managing that infrastructure, and you just worry about your workload. Whereas CloudRun on GKE is partly managed because it depends on where exactly you run your Kubernetes cluster. For instance, if you were to run it on GCP, then the only thing that you manage is the nodes or the worker nodes of the cluster that constitute that GKE cluster, right? Similarly, on a costing side, CloudRun fully managed is a pay per use or pay as you go model in which you absolutely don't make any upfront commitments or investments around it. Whereas in CloudRun on GKE, the investment comes in the form of the GKE cluster. So you have a recurring fixed price charge for the GKE cluster worker nodes. From a scalability point of view, CloudRun fully managed has a limitation of 1000 containers. So maximum it can scale is 1000 containers, and each of those containers can be up to 8 GB of RAM and 4 vCPUs. That's very important to understand. 8 GB of RAM and 4 vCPUs. If your workload needs more memory or CPU, then CloudRun fully managed may not be the best fit. But 95% of the cases we see that this is a good fitment for most of the customers' workloads. Similarly, there is no limitation for that on CloudRun on GKE because you can pick and choose the constituting nodes for the compute. Some of the use case we talk about later, but then the important thing to note here on the CloudRun on GKE is that a lot more tooling that comes along with this solution, because this is bundled as part of CloudRun Anthos solution or Anthos licenses really. So it's a good fit for both APIs, microservices, service meshes. Right, so an HTO component is thrown into the Anthos service mesh. It has got a binary authorization, which basically takes care of image signing and a lot more things. Right, so we can probably talk about it in a separate video. And one more additional thing apart from the dev experience and the logging monitoring are similar. There is another thing that comes handy with the Anthos license, which you don't get in CloudRun fully managed, is this tool called Migrate for Anthos, and I've done another video of this one, and I'll leave the link. The use cases, this is the most exciting part for me. So let's in fact ask what kind of use cases can it solve. Can it build asynchronous microservice? Can it be used to build REST APIs? Can it be used to build a maintenance job? Can it do ETL operations? Can it build a public? Can CloudRun be used to call code within a binary library for which you do not have the source code, like a third-party executable? Can it be used to run long-running jobs? Can it run off-the-shelf ISV application or COTS application? Can it be used to build machine learning services? So the answer to all these questions is yes, and I would highly recommend that you search for serverless expeditions, where two of the Googlers talk about these 9 workloads and how it can handle that. Okay. Hey, well, thank you for being with me on this. I wanted to keep this video short and not overwhelm you with a lot of detailing. So I'll create another video which will basically show the actual demo. And one of the use cases that we discussed, I'll pick it up. So please stay tuned, and thank you for being with me on this.